Something changed with 3I Atlas after it passed the Sun, and the images coming out of European observatories in the last 48 hours show something that has astronomers scrambling to recalibrate their models. The interstellar comet's tail isn't just growing, it's exploding in complexity and size at a rate that contradicts every prediction made before perihelion. We're talking about a tail that went from barely visible to spanning the apparent width of the full moon in the night sky in less than a week. And here's what nobody's talking about. The institutions that have the best data, NASA's Mars orbiters, the Hubble Space Telescope, the James Webb, they've gone quiet. Radio silent, actually, at the exact moment when 3I Atlas should be giving us answers. Let me show you what they don't want you connecting. The tail that shouldn't exist. On November 10th, Italian astronomer Gianluca Massi captured something that made him immediately publish a statement acknowledging how unusual his own data was. His images showed 3I Atlas had developed a sharply defined ion tail, even with a 61% moon washing out the sky, and the comet sitting just 14 degrees above the horizon. Now, for context, those are terrible observing conditions, the kind of conditions where most comets would be invisible. But 3I Atlas wasn't just visible, it was glowing intensely enough to cut through moonlight and atmospheric distortion. The tail structure Massi captured showed what he called intensifying activity. That's scientist speak for, this is accelerating beyond our models. 24 hours earlier, on November 8th, a team of Austrian and Italian astronomers captured images showing not one, not two, but at least 7 distinct tail structures radiating from 3I Atlas. 4 to 5 tails fanning out in multiple directions. Here's why that's a problem. Comets typically have 2 tails. One dust tail pushed by solar radiation pressure, one ion tail swept back by the solar wind. That's the pattern. That's what natural comets do. 7 tails, 7 different directional jets of material? That's not a pattern. That's chaos. Or it's something else entirely. The anti-tail pointing at the sun. But here's where it gets genuinely disturbing. Multiple observation teams have confirmed that some of these tails are pointing toward the sun, not away from it, toward it. They're called anti-tails, and while they're not unheard of in comet science, they're the result of very specific geometric viewing angles. You see them when dust particles are left behind in a comet's orbit, and we happen to look through that debris field edge-on. But 3I Atlas's anti-tail isn't behaving that way. British astronomers Frank Niebling and Michael Buchner captured images on November 9th showing an anti-tail extending roughly 10 arc minutes, about 1/3 the apparent diameter of the full moon, in the night sky, pointing directly at the sun. At the same time, a smoky main tail extended 30 arc minutes in the opposite direction. That's a 3-to-1 ratio. The tail pointing away from the sun is 3 times longer than the one pointing toward it. For a natural dust geometry explanation, those ratios don't make sense. Dust particles left in an orbit don't organize themselves into that kind of asymmetric structure. So what's pushing material toward the sun against the solar wind? Harvard astrophysicist Avi Loeb, who's been tracking this object since discovery, published calculations showing that for jets to penetrate over 1 million kilometers through solar wind pressure, they'd need to be carrying approximately 5 billion tons of mass per month. 5 billion tons! From an object that Hubble estimated has an upper diameter limit of 5.6 kilometers. Run those numbers. An icy nucleus that size doesn't have 5 billion tons to spare every month. It would have completely disintegrated by now. Unless the jets aren't coming from ice sublimation at all. The Webb data they're not discussing. Here's what makes this genuinely suspicious. We know the James Webb Space Telescope observed 3I Atlas on August 6, 2025. That's confirmed. That data exists. Loeb even referenced the Webb data in his analysis, noting that on August 6th, the comet was losing only 150 kilograms per second, a relatively normal rate for an active comet at that distance from the Sun. But then something changed, dramatically. By the time 3I Atlas reached perihelion on October 30th, amateur astronomers in European observatories were measuring a mass loss rate 10,000 times higher. Not double, not 10 times, 10,000 times higher. We're talking about 2 million kilograms per second. That kind of increase requires what Loeb calculated as a power law dependency with an index of negative 10.5. To put that in plain English, it means the comet's activity was accelerating exponentially as it approached the Sun, far beyond what heating from solar radiation can explain. So here's my question. Where's the Webb follow-up data? Where are the Hubble observations from late October and early November? We know these telescopes were pointed at 3I Atlas. NASA's own website lists Webb as one of the assets observing this object. But we haven't seen new images, no spectroscopy, no updated analysis, just silence. Meanwhile, amateur astronomers in Europe with backyard telescopes are capturing the most dramatic cometary activity of the decade, uploading it to public forums, and professional observatories are confirming their findings. Why is citizen science beating billion-dollar space telescopes to the story? The hydroxyl detection nobody's explaining. A week ago, a team at Auburn University published findings that NASA's Neil Darrell Swift Observatory detected hydroxyl gas, the chemical signature of water, coming from 3I Atlas. Now that should be normal. Comets have water ice. Water ice sublimates near the Sun and produces hydroxyl radicals. That's Comet Science 101. Except, Swift detected this hydroxyl signature when 3I Atlas was nearly 3 times further from the Sun than Earth is. At that distance, water ice should be completely dormant, frozen solid, inactive. They measured a water loss rate of 40 kilograms per second at a distance where solar system comets are, quote, relatively quiet. Their explanation? Maybe sunlight is heating small icy grains that were released from the nucleus, allowing them to vaporize in space rather than on the surface. But here's the problem with that explanation. It requires a continuous supply of fresh icy grains being ejected into space at massive distances from the Sun. What's ejecting them? If the surface ice is dormant and frozen at that distance, what mechanism is continuously throwing fresh material into space for the Sun to heat? They don't answer that. The paper just suggests it as a possibility and moves on. What December 19th will actually show us? 3I Atlas will make its closest approach to Earth on December 19th, 2025. At that point, it will be 270 million kilometers away. Still far, but close enough for our best instruments to resolve details we've never seen before. Hubble will be watching. Webb will be watching. Ground-based observatories around the world will have their clearest view yet. And here's what that means. We're going to see whether this object maintained its structural integrity after perihelion, or whether it broke up into pieces like a natural comet under thermal stress should have had. If it broke up, if we see multiple fragments, then the mystery has a conventional explanation. The extreme mass loss, the multiple jets, the unusual brightening, all explained by a fragile icy body that shattered under solar heating. But if 3I Atlas is still intact, if it's still a single coherent object after losing what should have been an unsustainable amount of mass, then we have a different kind of problem. Because that would mean it's built differently than any comet we've ever studied. It would mean something about its structure or composition is fundamentally not natural according to our current understanding. And the institutions that have the data to answer that question right now, NASA, ESA, the teams behind Hubble and Webb, they're choosing to stay quiet, while amateur astronomers do the work for them.
The tail of 3I Atlas is growing. The activity is intensifying. The data is piling up, and the silence from the organizations with the best instruments to explain it is deafening. Something changed with this object after perihelion. We're watching it happen in real time. We're just not being told what it means. December 19th is 36 days away. Mark your calendar, because either we're about to confirm the most spectacular cometary breakup in modern astronomy, or we're about to confirm something that's going to rewrite the textbooks. And based on what's being hidden versus what's being shown, I'm not sure which answer they're more afraid of. If you want to track 3I Atlas yourself and see these images as they come out, links to the observatories publishing real-time data are in the description. Don't wait for NASA.